There's 2 word problems we didn't get to. A certain culture of bacteria triples every 25 hours and grows according to this formula. A equals P base 3 to the RT. The initial count of a sample shows 1,000 bacteria present. Determine the rate of growth of this culture. How many bacteria were there 18 hours after the initial count? Approximately how many bacteria will there be in 2 days? Okay. So determine the rate of growth. Now, most times the formulas will tell you what the variables stand for too, right? But we know this is final amount, initial amount. R is the rate of growth, so I guess we're solving for R, and T is time. So this is the info they give us. So in part A, I'll use a darker pen. We're solving for R, agreed? The rate of growth. So let's see. That means the initial count is 1,000, that's my P. It triples. That's valuable, right? If I know that the population triples every 25 hours.
Can we just put 3 in 1?
Yeah, because that would mean, I guess according to the question, that would mean it would be 3,000, which is going to become 3. And this is my time, right? This is my rate of tripling.
125.
So T is going to be 25 hours, right? For this initial thing. So you can just put 3 in 1, Eduardo. Okay, so my base is a 3. And then R is what I'm solving for. R times 25. And I have to remember I'm solving in hours, right? Okay, so first thing I do is obviously divide that 1,000 out, and sure enough I get my 3 here. So 25R. Okay. So I have to log both sides, right? Log or ln. So that allows me to bring my exponent down. So I have log of 3 equals 25R log 3. So R is going to be equal to log of 3 divided by 25 log 3. Okay, rate of growth. Now, I have to solve for rate of growth, so I have to do that. My answer is going to be recorded as 3 decimals, but something important is going to happen here too. So let's take this. I have my log of 3 divided by 25 log 3. And I get my rate of growth is 0.009 to 3 decimals. However, I see there's 2 more parts to this question. How many bacteria were there 18 hours after the initial count? I need my rate of growth to solve that problem. And then how many bacteria will there be in 2 days? I need my rate of growth to solve that problem. In pre-cal, for this pre-cal, even though I have to respond to part A and give them an answer to 3 decimal digits, I have to solve B and C, and I have to use, I can't use a rounded answer when I'm solving for B and C, because B and C are new questions, right? And they want me to use this whole number. So you have 2 choices. This is important, part of logs and exponents. You can either record all these decimal digits on your paper and reprogram them into your calculator, just so that you don't lose any decimal digit numbers, or you can store your equation in your calculator if you know how to store. Now, it should be easy to learn how to store in your calculator. This is a really easy button to use on my calculator, because it clearly says store. So it's store, and it's asking me where I want to store. So I get to choose all these memory banks. So I'm just going to store mine in memory bank A. Okay? So when I want to recall from memory bank A, I can just call up my memory bank A, and it'll give me the number back. See? Now, all of you have scientific calculators. All of you should have a store button. But if you don't, the old-fashioned way is just to write this number out, right, and reuse it. Maybe you don't need 12 digits, but you definitely need up to 6 then if you're not going to suffer any errors. Know what I mean? You can't just use 0.009. You won't get a complete answer. Okay, how many bacteria were there 18 hours after the initial count? All right, so I'm solving for A this time, right? A equals 1,000 base 3. Now, here's where I have to use my store feature, right? And I'm going to go ... to remind myself I have it in my calculator, times 18. Okay, so A equals, so in my calculator I'm going to go 1,000 times 3 exponent, and I'm going to use my brackets, and I'm going to call up my number that I've stored in alpha A, times 18, and I get 1197, and I'm going to leave it here because bacteria are a living thing and I can't round. Because bacteria are a living organism, use whole numbers for units. So if this were people or dogs or cats or fish or bacteria, I'm going to use a whole number because you can't have part of a person. All right? Okay. Now, if you didn't, like, let's see. If I just call up my number here, let's say you can't find your store button. So I'm going to have to use at least 6 decimal digits. So I'm going to leave that here, and I'll redo the question doing sort of the old-fashioned way. Times base 3 exponent. So I'm going to do this 0.009105. I'll say, or I'll use the whole thing, 7877 times 18. And I get the same answer, right? So you can get the same answer, but you have to use more than 3 decimal digits, is what I'm saying. Okay, how about this one? How many bacteria after 2 days? So what formula will I use? Or can someone, I'm still looking for A, right? So what goes here? 1,000 base 3 0.009, right? My stored number times 24. Good work, Dee. So I had to convert that to, right, because the formula was given to me in hours. So I have to keep using hours. So this will be equals 24 hours. Okay, so same thing, 1,000 times base 3 exponent. I'm going to recall my number. And I get 1271 bacteria. Oh, sorry. It is 48. It is. Thanks, Abdullah.
Yeah, that's 48.
I don't know what I was doing here. Yeah. Because you said 48 first, and then you said 24, and I'm like, what? Okay, sorry, I got to redo my. So 1,000. Recall my saved number times 48. That'll be a lot more. 1616.
Oh, that doesn't make sense.
It doesn't, does it?
No, because
Hang on a sec.
triple after.
Yeah, let me see. 1,000 times base 3
And there was a mistake.
exponent. Okay, let's try this again. Did I screw my log 3 divided by 25 log 3? I get 0.04 this time. Is that what you got? Okay, watch me again. Log 3 bracket divided by bracket 25 times log 3 bracket, right? 0.04. Hi, Amanda. Don't be sorry. Okay, thanks, Eduardo. Someone's paying attention on a Friday, right? And it's not me. So I didn't have to use my fancy dancy store button, right, on the calculator. Okay, so let's change this. So 1,000 times 3 exponent.
Wait a minute.
That's better. So this one should be
It was 0.4 or 0.04?
0.04.
You got 0.4.
I think I used the right number in my calculator, but
Okay.
Oh,
double check. Ay, ay, ay.
so how do you pass the calculator?
Okay, so here I have 1,000 times 3 to the 0.04 times 18. So we get 22.0. You could go up or down with this. I'll round appropriately, I guess. So it'll be 22.06. Okay, 22.06. Okay, let's try this one now. I gotta redo this one. So this is 0.04 times 48. So 1,000 times base 3 exponent 0.04 times 48. That sounds better, right, Eduardo? 8243. So 8243 bacteria. Okay, that was a long, but going back to this though, quite often the rates are those big long decimals that don't terminate, right? So you have to use at least 6 decimal digits. Either write it down on a piece of paper so you can read one, or find the store button on your calculator, whatever works better for you. Okay. All right, let's do this one. This is a good one because those logs kind of tend to confuse people, I think. The decibel scale measures the intensity of sound. Okay, you saw a couple of those in your chapter test too. The loudness of a sound, L, measured in decibels, can be determined using this function. Loudness equals 10 times the log of I over I, that should be IO, by the way, not I10, IO, where I is the intensity of the sound and IO is the intensity of the quietest sound that can be detected. Okay, so this IO really represents it's insignificant, right? They're always comparing a loudness of sound to the loudness of, I think they had a whisper in your book, or it's the quietest sound you could ever detect with the human ear. So this is negligible, right? It's almost nothing. But that ratio is the comparison. So here it says, part A, the loudness of a rock concert is 120 decibels. So the loudness is 120. That is the I, right? So L equals 120, just to keep everything in perspective here. Calculate the intensity of this sound in terms of IO. All right, so this time, they gave us the L. 10 is part of the equation. The log is part of the equation. They're saying in terms of IO. When they say in terms of IO, you know IO is going to be part of the answer. They're just asking me to solve for I, right? So this time L equals 120. Solve for I. Okay, let's see what we can do here then. So here's my formula. I'm going to rewrite it in front of me so I have it right in front of me. Okay, so what do I have here? I have 120 equals 10 log I o. Okay, so what next? I'm trying to solve for this, right? So now what? This is my argument. So I'm trying to solve for the argument. So what would you do now? Like, think of this as one big X, kind of.
Yeah.
So now what? Negative 10?
Yeah.
Where do you get the negative 10?
So the 10 to the I on or divided by 10.
I think probably, why don't we just divide by 10, right? That would make things simpler right away. Divide by 10, divide by 10. So I'll get 12 equals log of IO. Okay, so I got this log, which is not pleasant. How do we get rid of logs?
Which one's
Yeah, so what is the base here? 10. You always have base 10s when you see that word log. So 10 to the power 12 equals
whatever the ratio
whatever it is, right? Whatever the ratio is. So that's all they're asking you for, really. So they're saying in terms of IO, so that's a really weird, but this is something I've seen on the final exam. If it says in terms of IO, they're just letting you keep IO in the answer. So I'm actually solving for I, right? So I guess I could write I equals 10 to the power 12 IO. So 10 to the power 12 is some huge number, right? I mean, 12 zeros, right?
That's all it is.
I think I would just leave it like that. The intensity of, intensity of, what was it again? The rock concert. The intensity of the rock concert is 10 to the 12 times more intense than the sound of a whisper. That tells you something, right? So the intensity of a rock concert, or this rock concert, is 10 to the 12 times as loud as the quietest sound recorded. That's their base, right? That's what their base is, whatever that is. I think, like I said, I think in the textbook it said it was a whisper. I think there's a sound even quieter than a whisper. That tells you why so many musicians become deaf, right? In their later years. That's it. Because when it says in terms of IO, you just leave that little IO there. No, it's I. That should be IO. Is that the one you meant, Rachel? Rahel, sorry. Yeah, it's IO. IO, like I0 is kind of like the starting point of sound. A sound at decibel 0 almost. That little O is like the quietest sound ever. Basically has no loudness to it. Like a quiet room. Yeah, when it says in terms of IO, they're just saying, like, you know, I multiplied these two together just to get I isolated.
Is it asking for I or I?
It's asking for I. And this is the answer. The answer would be 10 to the power times IO. Yeah, so it means,
Should we need to divide by 10?
no, no, no. This is what the answer would look like. That's it. Just leave the answer like that. Think of this almost as like a 1, like times 1. So 10 to the power 12 times 1, just 10 to the power 12. Okay, let's do B. If the intensity of normal conversation is 10 to the power 6 IO, see, this is how they're giving you their information. 10 to the 6 IO, how many times as intense is the sound of how many times as intense as the sound of normal conversation is a rock concert? So how much, how many times more intense is the rock concert compared to the normal conversation, right? So what do we have here? I'm going to move over on this side. Let's list our facts. So the rock concert intensity, we just found that out, was 10 to the 12 IO. Normal conversation, 10 to the 6 IO. So how many more times, how many times more powerful is this than this? We're comparing two things, right? So we compare them in a ratio, right? So comparing them, we get 10 to the 12 IO over 10 to the 6 IO. Well, the IOs are the same number, whatever they represent. So they just cancel out, right? Yeah. So the concert is 10 to the 6 times more powerful or more intense than normal conversation. If I asked you to answer as a whole number, what would that be? Yeah, isn't that 1,000,000? 10 to the power 6. If it's just a whole number, it's just a series of zeros, right? If you get something like 6.2 or 6.5, then it's different. You'd have to punch that into your calculator. But 10 to any whole number power, that just tells you how many zeros are in the answer. This would be 1, 2, 3, 4, 5, 6, 1,000,000 times as intense. That's amazing, isn't it? If you think about it. I think this is realistic data, so 1,000,000 times more intense than just normal everyday conversation. That's why anytime you're in an environment with loud noises, whether it's a rock concert or if you happen to work at a job with heavy machinery that's going all the time with those vibrations, you should always have protective hearing. Because even if it doesn't damage your ears now, it's cumulative. So you can have hearing damage later on in your life, right? So if you're in a work situation with loud noises, you should be wearing earplugs and those noise canceling headphones, right? Okay, so that's one of those weird log questions. I think there were a couple more. Anything else you want to look at?